All right, honors geometry, unit 1, day 2 notes. This is the video to accompany these notes. So what we're going to do now is we're going to, I'm going to go through an example of every single type of question that's on your unit 1, day 2 practice. And I'm going to try to go through this quickly because I know that this is a very quick group. You're very quick students as far as getting things, so I don't want to ramble on like I'm doing right now, and just have you keep fast forwarding. So we're gonna get right after this right now. Okay, we get right into this first page, and we look at the first type of question, segment addition and midpoints. So let's read it very carefully here. It says S is between Q and T. It is. It doesn't say that S is the midpoint. It just says S is between, okay? But it does say that R is the midpoint of QS. So I'm going to do this. This is kind of important. So watch this and do this. R is the midpoint of QS. That means that R splits QS into two congruent halves. So that means RQ and RS are congruent. So I just made one single congruent slash on each of those two separate segments, okay? So now they give us some measurements, okay? Some measures. RS is 5 units long, so that's this one right here. And it says that RT is 12 units long. Okay, and it says find QT. So QT, the length from Q to T, which is this entire segment, okay? So we've got this part of the entire segment, which they already gave us, RT is 12 units long. So if we had this part of the segment plus this part of the segment, we would have the entire segment. So we know that it's going to be 12 plus the measure of RQ. Well, look, we know that RQ and RS are congruent to one another. So if RS is 5 units long, RQ is 5 units long. So QT is going to be 12 units plus 5 units, which would be 17 units in length. Okay, move down to the next question. Midpoints. Okay, the midpoint of segment ST, which is the segment that joins point S and point T. Okay, the midpoint formula is as follows. We have the average of the two X coordinates, X1 plus X2 divided by 2, comma, the average of the two Y coordinates, Y1 plus Y2 divided by 2. Okay? As you can see, each point has an X and a Y coordinate, so our midpoint is going to have an X and a Y coordinate. Okay, so if we look at our two X's, so we got -7 plus -1 divided by 2. That's going to be our X coordinate. So -7 plus -1 is -8, divided by 2 is -4. Okay, that's my X coordinate. For my Y coordinate, we're going to add our Y's together. -4 plus 2, we're going to divide it by 2. -4 plus 2 is -2, divided by 2 is -1. So our answer is the point -4, comma, -1. Okay, always look to see if your answer is reasonable. -4, -1, looks like it's somewhere around here. And it does look like it's a midpoint. Okay, so I think our answer is very reasonable. Let's go to the next one. Okay, this next question is another midpoint question, but this time they gave us the midpoint. They gave us the midpoint and they gave us one endpoint. So I'm going to give you two quick ways to do this question. The first one is with the formula that we had. Okay? So our formula is that if I take x1 plus x2 and divide it by 2, I'm going to get the x of my midpoint. And if I take y1 and I take y2 and I add them and divide by 2, I'm going to get the y coordinate of my midpoint. Okay, now I'm just going to substitute what they gave me. All right, they did not give me one of the x's and one of the y's. So I'm going to call that x1 and y1. Okay, I'll put little ones here. All right, so they did not give me x1, but they gave me the other endpoints x, which is right there, -4. And the x of the midpoint is 1. Meanwhile, let's go right over to the y coordinates. Again, we're saying that this y coordinate is what we want. They didn't give it to us. Plus y2, which is the other endpoint's y coordinate, or 6, divided by 2 equals the y coordinate of the midpoint, which is 2. Okay, well now it's simple algebra 1 stuff. So let's look at the x coordinate. We can either multiply both sides by 2, or if you imagine putting a 1 under this 1, we could cross multiply. Either way, you're going to do the same thing. So if I multiply x plus -4, I'm going to call it x minus 4, times 1, get x minus 4. If you multiply on the other diagonal to cross multiply, you get 2. X minus 4 equals 2. Add 4 to both the sides of the equation. X is 6. For the y coordinate, again, we can imagine there's a 1 under this 2. Cross multiply the 1 times y plus 6. You get y plus 6. Cross multiply here. 2 times 2 is 4. Subtract 6 from both sides of the equation, and you get -2. Let's see if we could do this a different way, maybe a little quicker way. All right, if we just look at the coordinates without the formula, okay? Let's just look at the x's first. So this endpoint starts with -4, and it goes to the right to +1. So from -4 to 1, what happened? Well, -4 increased by 5. So that means that you have to do the same thing to go from the midpoint to the other endpoint. So you'd have to go 5 more units in a positive direction. So if I'm at +1 and I add 5, what do I have? 1 plus 5 is 6, which we know is right. For the y coordinate, change the color up here again. For the y coordinate, we started at 6 on the endpoint and we went down to 2. Okay, we went down to 2. So we went down from 6 to 2. So what happened there? We subtracted 4. So what are we going to do from the midpoints y to the other endpoints y? We're going to subtract 4 again. So what is 2 take away 4? 2 take away 4 is -2. So we got this with 2 minus 4. We got this one with 1 plus 5. So this could have been a quick, easy way to do it, but if you like the algebra way, you're all set. Let's look at the next question. Okay, this one is just naming things. You don't need to worry about adding, subtracting, multiplying, dividing, doing any of that stuff. All we're going to do is name some stuff. So we just have to memorize how to name things. Okay, easy enough. So let's look at angle GFE. Starts at G, makes a pit stop at F, and goes to E. So it's this angle right here. All right, the sides. Okay, well, the sides here, we're starting at point F, the vertex, And this side here, for example, goes infinitely through G. Well, we know that if it starts at a point and it goes infinitely one way, that's called a ray. And you always put the endpoint under the endpoint. So that would be ray FG. That's one of the sides of that angle. The other side, this one, again starts at endpoint F and it goes through E forever. So FE, ray FE is the other side of angle GFE, okay? Write two other names for angle 2. Okay, well, angle 2 is this other angle right here. All right, now just like in in letter A, they named the angle using 3 points. One on one side, the vertex, one on the other side. The vertex is always the middle point in your name, okay? So we're gonna call it angle, and I like to use a little slash here. You don't need to, but I remember my high school math teacher did that, and the reason was, you looked at these things, okay, 5 is less than 6, okay? Well, if that's supposed to be 5 times angle 6, they look the same. So he always just put a little slash there. I have seen a lot of math textbooks and mathematicians do it. So, I mean, I feel comfortable doing it, but I also feel comfortable if you don't do it. So if you just write your angle with the little alligator, that's fine. Okay, so angle 2, it could be E, vertex F, H, okay? So angle E, vertex F, H, or we could do the other order, H, vertex F, E. So the other way that you can name it, angle H, F, E. Okay? And now it asks finally for the vertex of angle 1. Vertex is just the point where the two sides meet. It's their common point. So angle 1 has a vertex of point F. You can write the word point in front of F if you want, but as long as it's a capital F, capital printed F, you're good. Okay, next question. So this next page looks at angle addition. Okay, we did segment addition where the pieces of a segment add up to the whole segment. So now we're going to take pieces of an angle, add up to a bigger angle. So if you look at this picture right here, and we look at angle 1, and we look at angle 2, okay, hopefully you can see that you take angle 1 and you add it to angle 2, and you get this big angle STF. That's all you really need to know in order to set up an equation for this question here. So it says the measure of angle ST, I guess that's a V. My eyes are failing me. Sorry about that. The measure of angle STV is 144 degrees. So this big one is 144. It says the measure of angle 1 is 68 degrees. And it says, what is the measure of angle 2? We can call it X. We like to do that in algebra. X marks the spot. So I hope that you can understand that you add the two small angles together. So we can call it X plus 68 equals the big angle, 144. Okay, easy peasy. We subtract 68 from both sides of our equation, and we are done. Okay, 76 degrees is the measure of angle 2. Okay, so you take that relationship, and we're going to do the same thing in this next question. It's just that now it just gives us a little bit more to work with. Okay, so here it says angle WXZ, which is this big angle. The measure is 104 degrees. Okay, so 104 degrees for the big angle. And then it says angle 2 as a measure, okay, M angle 2, measure of angle 2 is 60 degrees. But it's not just 60 degrees. Uh-oh. It's 60 degrees more than angle 1. Okay, so here's the deal. Let's call angle 1 X. So how do you express 60 more than angle 1, or 60 more than X? Hopefully you understand that it's X plus 60. So angle 2 is X plus 60. Angle 1 is going to be X, which is what we're trying to find. All right? So we go back to our angle addition postulate for the equation. I take the first angle and the second angle, and I set them equal to the big angle that has both of them in it. Okay, that's it. Now we're going to have to solve for X. Going to combine like terms. X plus X is 2X. We're going to subtract our 60 from both sides. So I get 2X equals 44. Divide by 2, so I get X is equal to 22. So the measure of angle 1 is 22 degrees. So I'll even write that out. The measure of angle 1 equals 22 degrees. Okay, all right, looking good. Next page. The next question still has angle addition postulate in it, but now we're going to use the term angle bisector, okay, just like we did some segment bisectors earlier, okay? So let's look at all the stuff they give us. Let's start with the measure of angle ABD is 101 degrees. Angle ABD is this giant angle right there. So 101 degrees. All right. The measure of angle EBD is 26. So EBD is this angle right here. That's 26 degrees. And now it says something very interesting. Segment BE bisects angle CBD. So here's CBD and here's BE. BE cuts angle CBD into two congruent, well, angles for this. Okay, so this angle and this angle are congruent. Well, that's kind of important because one of those angles is 26 degrees. So that means that the other angle is 26 degrees. Awesome. So let's find the measure of angle ABC. ABC is this guy right here, ABC. So we can call it X if you want. So you know that if we're going to do angle addition, let's add all of these little angles together. This angle plus this angle plus this angle. So you've got X plus 26 plus another 26 equals the whole giant angle, 101 degrees. Okay, combine like terms, 26 plus 26 is 52. Subtract your 52 from both sides. So X is 49. Okay, and the measure of angle ABC is 49 degrees. Let's lighten that up a little bit here. Cool. Okay. All right, this next one's probably going to be one of the easy ones we have. Complements and supplements. Well, complements are complementary angles. Complementary angles have a sum of 90 degrees. So two angles that add up to 90. Supplementary angles, two supplements, have a sum of 180 degrees. So in this particular topic, they may give you two angles that add up to a straight angle, a 180-degree angle. This is a 180-degree angle. If you add this angle plus this angle, angle 1 plus angle 2 would add up to 180. Well, in the question that we have here, we have an angle that has this little box. That little box indicates it's 90 degrees. It's a right angle box. So angle 1 plus angle 2 add up to 90 degrees. So the measure of angle 1 is 54 degrees. So 54 degrees plus the measure of angle 2 is going to equal the big angle. Well, we know that the big angle is 90. So, I mean, we could have gone 54 plus x equals 90 if we'd wanted to set it up without the measure and the angle and the degrees and all that. Either way, you're going to subtract 54 from 90, and you're going to get 36 degrees for angle 2. Okay. All right, let's scoot down to this last question on this page. And again, we have terminology. Okay. We are asked about linear pair. We're asked about vertical angles. And then we're asked about supplementary. Okay, we just covered supplementary. Supplementary angles are angles that have a sum of 180 degrees. That's it. A linear pair is just what the words sound like. A pair is two angles. Linear means they form a line. So if I have a line that's formed by angle 1 and angle 2, okay, then together that pair of angles forms a line. They're a linear pair. So angle 1 and angle 2 in my little drawing would be a linear pair. Okay. So question A says one pair of angles that form a linear pair. So if you take any line here, if I take this line, I could say this is a linear pair, 1 and 5. I could say this is a linear pair, 2 and 6. If I take this line, I could say 8 and 4 are a linear pair, or 3 and 7 are a linear pair, right? You can take any of those that you want. If I took this line here, I can take 3 and 4 there. So I'll do that. I'll take angle 3, angle 4. That is a linear pair. Okay. Vertical angles. Vertical angles, some people call them opposite angles. I don't like that, but anytime you have two lines intersecting, vertical angles. Vertical angles, right? So all you need to do to find vertical angles is look for an intersection of two lines. So let's look at this intersection right here. So you could say 1 and 6. That's a pair of vertical angles. Or you could say 2 and 5. That's a pair of vertical angles. On the other set, we could say 4 and 7. I'll say the very last ones. I'll say angle 3 and angle 8 are my vertical angles. So angle 3 and angle 8 are my vertical angles. All right, and finally it asks for supplementary angles, two angles that add up to 180. Well, linear pair are two angles that form a line, and a line, a linear angle, a straight angle, is an angle with a measure of 180 degrees. So I'm going to take angle 7 and angle 8. I know that they add up to 180 because I see that line that they form. They're a linear pair. So angle 7 and angle 8 are supplementary. They also are a linear pair. Okay, one more page. Okay, and these last two questions, my favorite type of questions in this unit, maybe, just because you get to do a little problem solving. It's kind of like a little puzzle. Okay, so all you need to remember is linear pairs add up to 180 and vertical angles are congruent. Those are the two things you need. Okay, so if we look at this question right here, Let's fill in what they give us. The measure of angle 3 is 128 degrees. All right, now we can find angles 1, 2, and 4 quickly and easily. Okay? As I said, vertical angles are congruent. So that immediately tells us that angle 1 is 128 degrees. Now, if I want to know angle 2 forms a linear pair with and is supplementary to angle 3. So 180 subtract 128 gives you 52. So that means angle 2 is 52 degrees. Once you have angle 2, the vertical angle to it is angle 4. This is also 52 degrees. You're done. Love those. Love those. Okay. The last question, again, you're looking at those two facts. Linear pair add up to 180. Vertical angles are congruent. So now you have some algebra. Okay, so I've got an X here, an X here, and a Z here. Okay, my piece of advice to you is take the two angles that have the same variable and make an equation to solve for that variable. So here you have two X's. So that means I have to find an equation for these two angles. So what is the relationship between those two angles? They're vertical angles, so their measures are equal. The angles are congruent. So we're going to take 14x minus 27, and we're going to take 8x plus 15, and we're saying they're vertical angles, so their measures are equal. Now, if they had been a linear pair, you would have first angle plus second angle equals 180. That's if they were a linear pair. These were not a linear pair. These were vertical angles, therefore they were congruent. So now to find x, okay, there's no like terms here, no like terms here. So I will cancel 8x. So I've got 6x minus 27 equals positive 15. I'm going to add 27 to both sides. I got 6x equals 42. Divide by 6, I got x equals 7. Yippee. Okay, so I've got x equals 7. That's half of my question. So how do I find z? Well, I know that this angle and z form a linear pair. So they add up to 180. Well, how big is 8x plus 15? Well, 8x plus 15 is 8 times 7 plus 15, because x is 7. 8 times 7 is 56. 56 plus 15 is what, 71? 56, 66, 71 degrees. Okay, so if this is 71 degrees, I know that z plus 71 gives me a line. So z plus 71 equals 180. Subtract 71 from both sides of that equation. I get z equals 109 degrees. We're complete. Day 2 done. See ya.